Okay, welcome to the Unit 5A Lesson 2 on multiplying and dividing radical expressions. So our objectives today are going to be simplifying radical expressions with indexes of 2, 3, or 4, and multiplying and simplifying radical expressions, dividing radical expressions with the same index, and we'll actually look at a few that have different indexes as well. So let's first start with understanding some of what we see here. So we've kind of talked a little bit about this already, that this number on the outside of this radical sign, right? We'll start with this. This is the radical sign. And this n here is called the index, also known as the root, right? And b here is called the radicand. All right, so these are understanding what you see. Now we'll talk a little bit about what we're doing here if we're simplifying, right? So the nth root for any number, right? And you have this whole long statement here, and you can read that and try to understand it. It basically comes down to some simple explanations that I think examples will help you to see better, right? So first, let's do this. Let's pretend that there's a set of parentheses in here, because that parentheses is important. So we're talking about negative 4 raised to the third power, which would give me negative 64. All right, because a negative times a negative times a negative would be a negative number. So understanding that would allow me to switch this negative 64 into negative 4 to the third power. So when I'm taking the third root of negative 4 to the third power, I will end up with negative 4. All right? And that's because for n, when the index is odd, right, there will be one real root. All right, and it's always just the same sign, right, of what the number is in the inside. If it's a negative 4, it's going to be a negative 4, right? So the third root of positive 8 is 2, and the third root of negative 8 would be negative 2. All right, so that's nice and easy when the index is odd. Let's talk about what happens when the index is even. So 3 to the fourth power, all right, you should memorize this and know that that's 81. If you have trouble with fourth, nice little general rule for fourth powers is that it's the number squared times the number squared, right? So that's 9 times 9, which is 81. All right, so again, I can break that down into the fourth root of 3 to the fourth power. Okay, so once you understand that, you see that that is 3. All right. So a couple rules here when we talk about even indexes, right? If the index, n is the index, if it's even, we need to pay attention to what the radicand is. If the radicand is positive, we only care about the positive root, right? And this is called the principal root. So when simplifying, we only care about the positive. Now, if we're doing an equation with variables, then we're going to have to worry about, all the solutions, all possible solutions. But if we're just simplifying, we're only caring about the positive root. We're only caring about the principal root. So what happens if the radicand is negative? Well, then you would start getting imaginary solutions. So if the radicand is negative, you're going to say there is no real solution. All right. So if the index is even and the radicand is negative, there's no real solutions. Now there's a little bit of kind of a special rule here. So the special rule applies when the index and this power are exactly the same. So if we're taking the nth root of a to the nth power, then we're going to kind of have a special rule, right? But this only applies when index and the power are the same. All right. So now if the index and the root are odd, then there's nothing really to worry about. The root is always the same sign. All right. Now, the special here is if n is even, well then we're always going to have a, right? Will always be, so the nth root of a to the nth power will always be the absolute value of a, right? So what does that mean? If I'm taking the fourth root of -2 to the fourth power, so we see how the index and the power are the same, the answer is 2, because -2 to the fourth power is 16, and the fourth root of 16 is 2. If I'm taking the fourth root of +2 to the fourth power, well then again, the fourth root of 16 again will give me 2. So again, it's a little bit of a special rule, is when these are exactly the same, then it's just going to be the absolute value of that number. Okay? So let's kind of see what this looks like in practice. All right, let's do a couple examples. So -54, the third root of -54, well, let's break that down. And I know -54 is -27 times 2. And you may be asking, why did I pick -27? Well, because that is -3 to the third power times 2. So I have the third root of -3 to the third power, so that's just -3. And I'm left over with the third root of 2. All right? Okay, so go ahead and pause the videos and try number 1, number 2, and number 3. I will, after unpausing the video, you should be able to see the answers. I'm not going to show the work that I did, but when we check your notes, we want to see the work that you did to get to these answers. So this is just a way for us to check that, make sure that people are listening to the video, watching the video, and doing this correctly, as opposed to just copying down what we're doing. So pause the video, try these, see if you can get to the same answers as what we have. Okay, so here's the solutions for number 1, number 2, and number 3. And when you come into class, we will have a worked out copy of the notes where you'll be able to check your work and kind of see if there's any mistakes, where the mistakes are. All right, so let's move on to simplifying radical expressions with variables. And in all of these problems, when we have variables under a radicand, we're always going to assume the variables are positive. All right, so when you're looking at these, we're going to kind of stretch this apart and break it down into simpler problems. All right, so if you have a whole number, try to break that down into a base with an exponent. So I know 32 is 2 to the 5th power, and then I have x to the 4th and y to the 7th. And all of that, I'm taking the third root. All right, so now, because I'm taking the third root, I'm looking for anything that can be exponents that are multiples of 3. So I can break 2 to the 5th down into 2 to the 3rd times 2 squared, right? X to the 4th becomes x to the 3rd and x to the 1st. y7 becomes y to the 6th times y to the 1st. And of course, I still always have that radicand with a third index. So how does that make this easier? Or maybe you're even wondering why I said y to the 6, right? Well, y to the 6 is just y squared to the third power, right? And so that means I can just simplify that to y squared in the end, all right? So let's now break this down, right? Remember, indexes, you can turn them into rational function, into rational exponents by dividing, right? So 2 to the third power, right? 3 divided by 3 is 1. So that 2 comes out, and that's gone. Let's write this in red. So that's gone. And we'll leave that one alone. X to the third root of x to the third is x, and that's been used. The third root of y to the 6th is y squared. And then I've used that one up. So now we'll just have our radicand with our index 3. Now notice I always, once I make my radical sign, I always throw my index in right afterwards to make sure I don't forget it, right? Get in the habit of writing that, because a lot of times people will make mistakes by dropping their index. Make sure if you write it right away, you're not going to forget it. So let's simplify this. 2 squared becomes 4. X to the first we'll just write as x, and y to the first we'll just write as y. And there's our simplified version of the example. All right, so go ahead and pause the video, attempt these two problems, and then come back and check your answers. If you didn't get it right, make sure you ask about it in the beginning of class, or check our answer key when you get to class. All right, so pause the video and try number 4 and number 5. Okay, so here's the solutions for number 4 and number 5. Again, make sure you have your radicand index here of 4 and your radicand index of 5. If you're forgetting to write those down, again, make sure you write them down first so that you don't forget them. All right, let's look here at multiplying and dividing when the indexes are the same. All right, so we've done this before with square roots. Well, if the indexes are the same, it's the same principle, right? You just multiply the radicands together, so you get AB, and the index stays the same, right? We're not going to make this n squared or any crazy thing like that. If the indexes are the same, it stays the same, right? So let's take, for example, the cubed root of 3 multiplied by the cubed root of 18. Now we could just multiply those together to get the cubed root of 54 and then simplify that as much as we can. But if you're thinking a little strategically, you know, I would much rather reduce the cube root of 18 than the cube root of 54. So if I do it that way, where I have the cube root of 3 to the first times, I know this is 9 times 2, so that's 3 squared times 2. So with that already broken down, instead of making the numbers bigger, make the numbers smaller. And that gives me the third root of 3 to the third power times 2. Well, I know the third root of 3 to the third power is 3. And I know this just stays under here as 3 to the third root of 2. All right, so just a little bit of strategy, trying to make, instead of making the numbers bigger, try to make them smaller first. All right, so same thing with division, right? You can make it into one big division problem, the nth root of a divided by b, right? So just go ahead and do the division and simplify it. Make the numbers bigger or smaller before you make them bigger. All right, so okay, so now let's look at some examples and try to see what we can figure out here. So we're multiplying here. Now I'm taking the third root. I see a negative here and a positive here, so that's going to end up being a negative number. So I'm just going to pull that out right away. All right, so there's a negative number now. Put this together, so that's a 4, so that's really a 2 squared. And then I have an x to the 4th and a y squared. and then I have another 2 to the first, x to the fifth, y. So what does that give me? That gives me a negative, oh, forgot my index. So third root of 2 to the third power, x to the ninth power, and y to the third power. Well, that's nice. They're all multiples of 3. So negative 2, x to the third, y. And there's my example. All right. So let's check over here. Again, we're just going to make this into one big problem. My index is 3. So negative 64 x5 over 4x to the fourth power. So if that's my division problem, negative 64 divided by 4 is negative 16. And again, division we subtract, so that gives me x. So I'm left with the third root of negative 16x. So let's bring that negative out. And let's break that 16 down into 2 to the fourth power times x. So that's going to give me negative 2 with a 2x left behind. Okay. So there's our examples of what we're actually doing here. Go ahead and pause the video, try number 6, try number 7, make sure you're showing your work. There are multiple steps that need to be done, so we should be able to see your steps to help you figure out where you're making mistakes if you are. So pause the video, try number 6 and number 7, come back and check your work. And here are our solutions for number 6 and for number 7. If you had any trouble with this, just talk to us in class, check your answers on our hard copy answer key, and we'll be happy to help you. All right. So now we're going to look at what happens when we're multiplying and dividing with different indexes. And so this really should be an A here, right? So here we see our index here is N and Q, and that's just basically designed to show you that they're different, right? They're two different numbers. So when they're two different numbers, right, when you multiply them together, you need to change them to rational exponents. Right? Change to rational exponents. That's what this says. Once you get into rational exponents, then we can start dealing with exponent rules. So a to the 1 over n times a to the 1 over q, right? So we're going to add those. So we get a to the 1 over n plus 1 over q, right? And then you're going to be adding and subtracting fractions, get the denominators to be the same, and move on from there, right? And the same thing is going to be true for division, right? If it's a to the nth power over the q root of a, we're going to end up with a to the 1 over n minus the 1 over q. All right? So multiplication you add, division you subtract. But in either case, if the indexes are different from each other, you have to use rational exponents. All right? So these are all going to be examples. We're going to do these all together, and then that'll be the end. All right? So let's switch this into 7 to the 1 over 3 times 7 to the 1 over 4. My common denominator would be 12, so that gives me 7 4 over 12 times 7 to the 3 over 12. When's that jump being 7 to the 7 over 12, right? All right, now here my indexes are not the same, a 2 and a 32. So before my radicands need to be the same, a 2 and a 32 are not the same. But 32 can be converted, right? It can be converted into 2 to the 5th power. So now they're the same, right? So if we ever give you a problem like this with different indexes and different radicand, try to turn that radicand, simplify it into a like radicand, right? So that gives me 2 to the 1/3 times 2 to the 5/4, which again, a common denominator of 12, gives me 2 to the 4/12 plus 15/12, which is 2 to the 19/12. All right. And our last example here is a division problem. And we chose this to kind of show one more aspect. So this is a 1/4. Now if I subtract these, I have more on the bottom. So this gives me x to the 1/3. All right. Now there's a problem with that. Because that fractional exponent is in the denominator, denominators must have whole number powers, exponents. Right? So we're going to need to rationalize this denominator, right? So if I have 1/3, what do I need to add to 1/3 to get to a whole number? That would be 2/3. So I'm just simply going to multiply by x to the 2/3 on the bottom and x to the 2/3 on the top. So x to the 2/3 over 4x. And that's my solution in rationalized denominator form. All right. So if you have any questions, we'll be happy to discuss it in class. And have a good day.